Applications of slope. So slope has many applications in the real world whenever you're dealing with things that are linear or that have some kind of a rate of change. And so got a couple of examples here of word problems where slope is at the heart of the problem. So construction laws regarding access ramps for the disabled require that for every vertical rise of 1 foot, there must be a horizontal run of at least 12 feet. So already in this word problem, hopefully you recognize things that sound like slope, that for every vertical rise, we've got some ramp, and every time that they rise 1 foot, you have to run 12 feet. Okay, and so that ends up giving us a slope of 1 over 12. So what they're saying is that ramps have to have a slope of that or less. It has to be that steepness or less steep. So you see a ramp that is 3 feet tall and 36 feet wide. Does this ramp meet the construction law? Well, the easiest thing to do is to set this up as a ratio as well. 3 over 36. Simplify, we get 1 over 12. So we would say, yes, it meets the law. Now, it was really convenient that what we ended up with was actually the same. Otherwise, we would probably have to take out our calculator and get decimals and compare to see which one was actually smaller. The second example, the data collected suggests that chocolate consumption is on the rise. In 1990, 2 million pounds of chocolate were consumed, compared to the 10 million pounds consumed in 2010. Find the average rate of change of chocolate consumed between 1990 and 2010. And just as a note, the statistics in this problem are completely made up by me, so don't go telling people about how we're consuming more chocolate now, although we probably are, but not with this exact data. So if you think about it, they're telling us about 2 points. In 1990, we consumed 2 million. And in 2010, we consumed 10 million. And so we want the average rate of change, which is the same as the slope. So we do the slope formula. We label these x1, y1, x2, y2. It is important that the second point is the point later on in time. And the only thing it changes actually is it would give us a negative sign the other direction, which we wouldn't want. So we subtract our y's on top, 10 million minus 2 million. We subtract our x's on the bottom. And 10 million minus 2 million is 8 million. And I'm just abbreviating instead of writing out 8 million. 2010 minus 1990 is 20. So there 8 million pounds of chocolate were consumed, 8 million more pounds of chocolate were consumed over that 20 years. And so then you would want to probably get your calculator out and actually type out 8 million, which has 6 zeros, and then divide it by 20. So the average rate of change should be 400,000. And our units are, think about what was on top. We had pounds. We had millions of pounds, but now we don't. On top is pounds. On bottom is years. So our units here is that we have 400,000 pounds per year. And that's our answer.